Galileo Galilei was an Italian astronomer born in Pisa in 1564. He is often referred to as the father of observational astronomy, a title well-deserved given his numerous contributions to the field. He was also a physicist, engineer, philosopher, and mathematician. His diverse interests and talents allowed him to make significant advancements in various scientific disciplines. Galileo lived during a time of great change and discovery, from 1564 to 1642. This period, known as the Renaissance, was marked by a renewed interest in science, art, and exploration. Galileo is considered one of the founders of modern science. His methods of systematic observation, experimentation, and mathematical analysis laid the groundwork for the scientific revolution. His discoveries revolutionized our understanding of the universe. Galileo made groundbreaking observations that challenged the established views of his time. He used the telescope, a new instrument at the time, to observe the heavens. This tool allowed him to see celestial objects in unprecedented detail. He discovered mountains on the moon and 4 moons orbiting Jupiter. These observations provided concrete evidence that not all celestial bodies revolved around the Earth. He observed the phases of Venus, which supported the heliocentric model proposed by Copernicus. This was a significant finding that further questioned the geocentric model. These observations challenged the long-held belief in an Earth-centered universe. Galileo's work provided strong evidence for a sun-centered solar system. Galileo's work got him into trouble with the Catholic Church. His support for the heliocentric model was seen as heretical, leading to a trial by the Inquisition. The Church supported the geocentric view, which placed the Earth at the center of the universe. This was in line with the teachings of Aristotle and Ptolemy. Despite facing opposition, Galileo remained a staunch advocate for the heliocentric model. He continued to write and publish his findings, even under house arrest. His courage and pursuit of truth paved the way for modern astronomy. Today, Galileo is celebrated as a pioneer who dared to challenge the status quo and expand our understanding of the cosmos. Galileo was born in Pisa, Italy, in 1564. This picturesque city, known for its iconic Leaning Tower, was a hub of culture and learning during the Renaissance. Growing up in such an environment, Galileo was exposed to a rich tapestry of ideas and traditions that would shape his future endeavors. His father, Vincenzo Galilei, was a talented musician and a music theorist. The Galilei family placed a high value on education and intellectual pursuits. From a young age, Galileo was encouraged to explore various fields of knowledge, including music, which played a significant role in his early education. At the age of 17, Galileo enrolled at the University of Pisa to study medicine, following his father's wishes. The university was one of the most prestigious institutions of higher learning in Italy, attracting scholars from all over Europe. However, Galileo's true passion lay elsewhere. Despite his initial focus on medicine, Galileo was irresistibly drawn to the world of mathematics and physics. He found himself captivated by the works of ancient Greek mathematicians and the emerging scientific ideas of his time. His curiosity and determination led him to question established beliefs and seek new understanding. After several years of study, Galileo made the bold decision to leave the University of Pisa without completing his degree. This was a risky move, but Galileo was determined to pursue his own path and follow his intellectual passions. Undeterred by his departure from formal education, Galileo continued his studies independently. He immersed himself in the works of prominent mathematicians and scientists, conducting his own experiments and developing his theories. His home became a center of learning and discovery. Galileo's early experiments focused on the principles of motion and mechanics. He conducted groundbreaking studies on the behavior of falling objects, challenging the long-held views of Aristotle. These experiments were crucial in laying the groundwork for his later, more famous discoveries. By questioning Aristotle's widely accepted ideas, Galileo sparked significant controversy within the academic community. His willingness to challenge established doctrines demonstrated his commitment to scientific inquiry and his belief in the power of observation and experimentation. Galileo's meticulous work on falling objects and pendulums not only advanced the field of physics, but also laid the foundation for his later discoveries in astronomy and motion. His innovative approach to experimentation and his keen analytical mind set him apart from his contemporaries. These early achievements established Galileo's reputation as a brilliant and controversial scientist. His relentless pursuit of knowledge and his groundbreaking contributions to science would eventually earn him a place among the greatest thinkers in history. In 1609, Galileo heard about a new invention from the Netherlands. It was called the telescope. Intrigued by its potential, Galileo built his own telescope. He improved its design and magnification power. The telescope revolutionized astronomy. It allowed Galileo to observe the heavens in unprecedented detail. He became the first person to see the craters and mountains on the moon. Galileo's observations challenged the prevailing view of the moon as a perfect celestial sphere. His telescope revealed a world with its own unique features. Galileo's telescope revealed a universe full of wonders. He observed 4 celestial bodies orbiting Jupiter. These became known as the Galilean moons: Io, Europa, Ganymede, and Callisto. This discovery provided evidence against the geocentric model. It showed that not everything in the universe revolved around the Earth. Galileo also observed the phases of Venus. The phases were similar to the moons. This observation supported the heliocentric model. The model placed the Sun at the center of the solar system. Section 5. Champion of Copernicus. Nicholas Copernicus was a Polish astronomer. He proposed the heliocentric model in the 16th century. Galileo's observations provided evidence to support Copernicus's theory. Galileo became a vocal advocate for the heliocentric model. He wrote and lectured extensively on his findings. He argued that the Earth and other planets revolved around the Sun. Galileo's views challenged the teachings of the Catholic Church. The Church held the geocentric model as dogma. Section 6. Conflict with the Church. The Catholic Church viewed Galileo's support for the heliocentric model as heresy. Church authorities warned Galileo against promoting his views. They argued that it contradicted Scripture. Despite the warnings, Galileo continued to defend the heliocentric model. He believed that science and religion could coexist. He argued that the Bible should not be interpreted literally when it came to scientific matters. However, the Church saw Galileo's ideas as a threat to its authority. They condemned the heliocentric model as dangerous and heretical. Section 7. The Trial and House Arrest. In 1633, Galileo was summoned to Rome by the Inquisition. This marked the beginning of one of the most famous trials in history. Galileo, a man of science, was now at the mercy of the Church, which saw his teachings as a direct threat to its authority. He was put on trial for heresy. The courtroom was filled with tension as Galileo faced his accusers. The Inquisition was determined to make an example out of him. The Church accused him of teaching and defending the Copernican theory, which posited that the Earth revolved around the Sun. Galileo defended himself eloquently, presenting arguments and evidence to support his views. However, his defense fell on deaf ears. Despite his compelling defense, Galileo was ultimately forced to recant his views under the threat of torture. The fear of physical pain and the overwhelming power of the Church left him with no choice but to publicly renounce his findings. The Church found Galileo guilty of vehement suspicion of heresy. This verdict was a significant blow to the scientific community, as it sent a clear message about the dangers of challenging established doctrines. Galileo was placed under house arrest for the rest of his life. Confined to his home, he was cut off from the academic community and the world at large. Despite the restrictions, he continued his scientific work. Galileo's spirit remained unbroken, and he used his time in isolation to further his research and write some of his most important works. He made significant contributions to the study of motion and mechanics. His work laid the foundation for future scientists and cemented his legacy as one of the greatest minds in history. Galileo's perseverance in the face of adversity remains an inspiration to this day. Section 8. The Enduring Legacy of Galileo. Galileo died in 1642, but his impact on science was profound and lasting. His observations and discoveries revolutionized astronomy. They paved the way for the acceptance of the heliocentric model. Galileo's emphasis on observation, experimentation, and mathematical analysis laid the foundation for the scientific method. He is considered the father of modern science. Galileo's courage to challenge established beliefs inspired generations of scientists. His pursuit of truth, despite facing opposition, remains an enduring example of scientific integrity. Section 9. Conclusion: the father of modern science. Galileo Galilei was a visionary scientist. His discoveries transformed our understanding of the universe. His invention of the telescope opened up new frontiers in astronomy. Galileo's observations challenged the prevailing geocentric view. They provided evidence for the heliocentric model. His courage to defend his beliefs even in the face of opposition made him a symbol of scientific freedom. Galileo's legacy continues to inspire us today. His relentless pursuit of knowledge and his unwavering belief in the power of reason remain cornerstones of modern science.